You know, when we talk about construction, it's usually about doing less harm. But what if the buildings we create could actually do some good? Today, we're going to dig into a new material called EcoSol that's trying to do exactly that. It's all about turning old construction wastes into a brand new foundation for a greener future. It sounds a little crazy, doesn't it? I mean, you look at our skylines, and they're all steel and concrete, materials that come with a massive environmental price tag. But the story of how we build is starting to change. We're going to explore how one innovation is trying to completely flip the script. But before we can get to the solution, we really have to get our heads around the size of the problem. You could say there's a crack in the very foundation of modern construction, and it's built on the huge and often invisible environmental cost of the materials we just take for granted. So here's the real clash we're dealing with. On one side, you've got materials like concrete, which are responsible for something like 8% of all global CO2 emissions. It's staggering. And on the other side, there's this urgent growing demand for a totally new way to build. This isn't just a nice to have anymore, it's an absolute necessity. And it's this exact gap that innovators are racing to fill. And one of the most promising answers to that call is this material, EcoSol. It's an innovation that wasn't born in a quarry or a mine, but literally from the rubble and waste of our existing cities. It's been designed from the ground up with sustainability baked right in. So what is this stuff really? Well, at its core, EcoSol is a pretty clever recipe. You start with recycled aggregates, which is basically just a fancy way of saying old construction materials getting a second chance. Then you mix that with water, some mineral additives, and a few special chemical activators that help it all bind together, without needing tons of pressure or heat. The end result is a material that's designed to be both incredibly ecological and surprisingly easy to work with. Now, this isn't just some eco-friendly mixture, it's a seriously engineered material. And there are two features here that really jump out: self-compacting and tailored recipes. Self-compacting means it flows and settles perfectly all on its own, which, trust me, is a total game changer on a construction site. And the fact that you can tweak the recipe means engineers can get the exact strength and properties they need for any specific job. It's the whole package, brains and brawn. So all these features add up to what you could call a three-way advantage. Let's break down how EcoSol delivers a win for the planet, a win for the project budget, and a win for the actual physical build itself. First up, the planet. And this is the big one, right? By using 100% recycled aggregates, EcoSol directly attacks our massive landfill problem. Every single ton of this stuff is a ton of waste that's been given a new, useful purpose. It closes the loop, which means we don't have to keep digging up the earth for new materials, and it dramatically slashes a project's carbon footprint. Second, let's talk about the project's bottom line. Just picture a construction site without the constant, ground-shaking roar of compaction machinery. Because EcoSol flows and settles perfectly by itself, you get to eliminate that entire noisy, expensive step. That's a huge saving in machinery, in fuel, and in labor hours. Then you add in the tailored recipes that cut down on wasted material, and the economic argument becomes incredibly clear. And third, there's the technical advantage. For an engineer, this is all about peace of mind. When a material settles on its own like this, it creates a perfectly uniform density. There are no hidden air pockets, no weak spots. That means you get a rock-solid structural integrity you can really count on. This, plus the ability to customize its strength, gives architects and builders a really powerful and reliable new tool in their toolkit. So, okay, a material that's good for the planet, good for the budget, and good for the engineering? It almost sounds a little too good to be true, doesn't it? But where is it actually being put to the test out there in the real world? Let's take a look at its applications, from simple foundations to major infrastructure projects. Its versatility is seriously impressive. It's tough enough for all the heavy-duty stuff. We're talking foundations, roads, and locking pipelines in place. But it's also precise enough for more delicate jobs, like filling in tricky underground cavities. And this one's really cool. It's even being used to create biotopes, which are basically custom-built habitats designed to help restore local ecosystems. You see, what all these different applications have in common is that they lean on EcoSol's core strengths. Its ability to be customized makes it perfect for complex civil engineering jobs, while its self-settling nature is just ideal for securing critical infrastructure, like pipelines, making sure they have a stable foundation for years and years to come. All right, let's pull back from the dust of the construction site for a minute and just look at the bigger picture. What does an innovation like EcoSol really mean for our goal of building a genuinely greener future? I think the crucial takeaway is this. Materials like EcoSol are so much more than just clever engineering. They represent a fundamental shift in our mindset, a move away from a take, make, and waste model to a circular one. This is how we start to build cities that don't just consume our planet's resources, but actually help preserve them for the future. Look, EcoSol is one powerful, fascinating piece of the puzzle. It's a huge step forward that proves a better way of building is absolutely possible. And that really leaves us with the ultimate question, doesn't it? What comes next? What other breakthroughs are just waiting out there to be discovered that will help us finally build a truly sustainable world? Now that's something we're thinking about